In this video, we'll take up the homework on transformation of exponential functions. The first question is pretty straightforward. You just basically have to establish what A, K, D, and C are. But be careful for 1C because you can't establish what A, K, D, and C are because the bases are different. So if the bases are different, you need to make the bases the same, and then you can establish the parameters and then the transformations. So change 4 to be 2 squared, and you'll realize that using the power law of exponents, you have 2 to the power of 2x, which makes it a lot easier to work with. And because now you can establish that k is equal to 2. For question 2, the graphs that were there were beautiful in the answer key. So I didn't really give you a graph, but what I did do is I showed you the original points. I gave you the mapping rule for each, and I gave you the new points for the transform function. Okay, but you can plot the points easily by yourself. For 3a, they want me to graph it. Once again, the equation has a very nice graph, or otherwise you can use Desmos. They want me to identify domain and range. Yep, no problem. Domain is all real numbers. Range is any value greater than 0. X and y intercepts, you can see the graph. Asymptote, you can see the graph. But based on transformations, it makes sense that the horizontal asymptote has an equation of y equals 0. Okay, so for 4, you want to change the base to 4, and you want to change the base to 2. Well, 16 is 4 squared, and 16 is also 2 to the power of 4. So that's how I approached 4a and 4b. And then, of course, you can use transformations. Sorry, for 4c, you want to graph on this. Yeah, how do you know that they represent the same equation or same function? You can graph on the same set of axes, and you'll notice that the graphs are the same. Okay, so for question 5, great question. You're told the y-intercept, you're told the horizontal asymptote, but unfortunately, you'll see that there are infinite values that can be for b. Okay, like, yeah. So as long as the equation is the form of y equals 3 times b to the power of x plus 1, and once again, b is greater than 0 and b can't be 1, then you have an exponential function that satisfies the properties. Okay, and lastly here, I just need to prove to you that 2 to the power of negative x is equal to half the power of x. Lots of different ways to do it. This is just one of the ways. In fact, you could do it in one step because if the exponent is negative, you can just take the reciprocal of the base. It was a very interesting question. I really don't know why that was there, but yeah, it's good practice. Can't hurt.